All right, today we're diving into a really cool engineering method. It's all about finding one tiny problem in a system that's miles long and buried deep underground. It's called nodal analysis. And honestly, it's kind of like performing surgery on a patient you can't even see. So let's just jump right in with a puzzle that petroleum engineers face every single day. Imagine a highway, right? Except this one is vertical, it's miles long, and it's totally invisible. Now, how in the world are you supposed to find the one spot where everything is getting jammed up?
Okay, first things first, we need to get one thing straight. An oil well is not just some simple straw you stick in the ground to suck up liquid. You've got to think of it more like a super complex, multi-stage transportation system.
I mean, the journey for just a single drop of oil is pretty incredible. It starts way down in the reservoir rock, then it has to squeeze through these tiny holes called perforations to get into the well. From there, it travels up miles of tubing, passes through a valve called a surface choke, and then finally lands at a piece of equipment called a separator. A restriction at any one of those points can create a massive bottleneck for the entire system.
But here's the real kicker. That traffic jam is completely invisible. You can't just, send a camera down there and take a look. So finding that one single component that's holding everything back, well, it's absolutely crucial for efficiency. And let's be honest, for profitability. So how do engineers find this hidden bottleneck? Well, they definitely don't just guess. They use this brilliant diagnostic tool that pretty much acts like a GPS, pinpointing the exact location of the problem within the whole system. And this is where nodal analysis comes into play. See, instead of looking at each part by itself, it gives you a complete, holistic view. It treats the well not as a bunch of separate pieces, but as one single, interconnected system, where a tiny change in one spot can send ripples through everything else. So the way this analysis works is by breaking the entire system down into three key areas. You've got the reservoir's ability to actually deliver the fluid, then the performance of all the pipes bringing it up, and finally the performance of the equipment on the surface. Nodal analysis looks at all three of these together to get the full picture. So how does this whole thing actually work? Well, at its heart, it really boils down to a beautifully simple concept that we can all understand. It's all about balancing supply and demand. Okay, part one. First, engineers map out the supply curve. It's got a fancy name, the Inflow Performance Relationship, or IPR, but all this graph really shows is the reservoir's natural ability to push fluid into the well. Basically, it's what the well can give. Then comes part two. They map out the demand curve, which is also called the tubing intake curve. This one shows the capacity of all the hardware, the pipes, the valves, the chokes, to carry that fluid up to the surface. It's what the system can take. And the logic here is really simple, but it's also incredibly powerful. A well can't produce more oil than the reservoir can supply, right? And it can't produce more than the pipes can actually handle. So the actual production rate, it has to be where those two lines cross. And that intersection point, it's not just a guess. It's the calculated reality of what that well is producing right now. It's called the operating point, and finding it is the key to unlocking the well's true potential. Once you've found that operating point, that's when the real magic begins. You can start asking, what if? This analysis lets engineers run simulations on a computer, testing out all sorts of different scenarios before they spend millions of dollars trying them out in the real world. So for example, what if we lower the pressure at that final separator? Well, the analysis can predict exactly how much more production you'll get, but it will also calculate the higher energy cost for the compressor. This lets you make a pure business decision. Is the extra oil really worth the extra cost? It also helps find what you could call the Goldilocks tubing size. If the pipe is too small, it just chokes off the flow. But if it's too big, the flow can become unstable and really inefficient. The analysis finds the size that is just right to get the most production, safely and stably. But the real power of this method goes way beyond just one or two components. It's about being able to see and analyze the entire production highway from the very beginning to the very end. The true beauty of nodal analysis is just how incredibly versatile it is. You can use it to evaluate the impact of pretty much any part of the system you can think of, from the safety valves deep underground to the size of the flow line running on the surface. And by analyzing each and every one of those components, it can finally answer the single most critical question for any well. Is the bottleneck in the rock, or is it in the steel? Is the problem with the reservoir's natural ability,
Or is it with the equipment we installed?
Nodal analysis is just a powerful reminder that to truly optimize any complex system, whether we're talking about an oil well, a supply chain, or even just your morning commute, you first have to find its true limiting factor. The bottleneck is always hiding somewhere. The trick is knowing how to find it.